Hello, my name is Zarfan Maisha.
Hey guys, my name is Muhammad Abdul Syarab Isa.
Hi, my name is Faizan.
Hello, my name is Hafiz Alimi.
Hello, my name is Akram. Hi, we are from group 3T32, and today I will explain you the distillation process of a distillation column. Okay, to others that who still don't know, distillation is a process of separating substance from a liquid mixture. Distillation is one of the most common liquid-liquid separation process and can be carried out in a continuous distillation column. Distillation also can manipulate the different boiling point of each substance, which is to be separated using heat. The heat will cause component with low boiling point and high volatility to be easily vaporized and go out through the condenser as vapor, leaving the less volatile component remain liquid in the column. Okay, I will explain to you what is overhead. Overhead is a vapor that pass through the condenser, as you can see from this diagram. The vapor that pass through the condenser is divided into two parts, which is reflux and overhead. Reflux is returned back to the distillation column to be used in the distillation process. Okay, I will explain to you what is bottom product. Bottom product is liquid that partially vaporized by reboiler, as you can see from this diagram. The liquid that pass through the reboiler is been divided into two phase, which is vapor and liquid. The liquid product is taken off as bottom product, and vapor product is taken off back into the distillation column as boiled up. Okay, as you can see from here, acetone has lower boiling point than acetic acid, which cause the product in the overhead product mostly composed of acetone, which is 80%. Okay, I will explain to you the methodology of our project. Before entering simulation mode, we will have to key in our component, which is acetone and acetic acids. The fluid package used in our process is antoine, and our process unit involve one, which is distillation column. And after that, we can enter this simulation mode. After enter simulation mode, we have to key in this value, which is given in the equation, the temperature, pressure, and molar flow. And then, as you can see from this diagram, we have to key in the value of delta P and P ray boiler, which is also given and specified in the problem.
For my part, we change the number of stage in the distillation column, and now I will tell you about the energy that are being produced from the distillation column. We change for each stage, each value of stage that we change, the energy value remain constant. So meaning that the amount of stage will not affect the amount of energy that are being produced from the distillation column. And then I will tell you about the composition, whereas the increasing number of stage will mean the increasing number of acetone in the composition of the overhead, which means that the amount of the value of stage will affect the efficiency and the composition of the acetone.
Guys, so we have manipulated the stage efficiency to 0.2, 0.4, 0.5, 0.6, and 0.8. But theoretically, the vapor leaving each tray and the liquid leaving each tray is equilibrium, means 100% efficiency. But actually, the stages are not perfect, which means when we change the stage efficiency to 0.2 until 0.8, the composition of overhead and bottom product is not equilibrium, which are due to insufficient time of contact and inadequate degree of mixing. The energy of the condenser and the boiler. also decreasing as we increase the stage efficiency from 0.2 until 0.8. So, when to achieve the desired degree of separation, more stages have to be added in the stage and in order to increase the stage efficiency. So,
So I will continue with this set of data, which is we set the reflux ratio as the manipulated variable. So reflux ratio. So first of all, what is reflux? Reflux is the technique used involved in the condensation of vapors and the return of this condensate product back to the distillation column. So reflux ratio means the ratio of the amount of reflux that went back to the distillation column and then the amount of reflux that we collected as distillate. So I'm going to highlight at the highest reflux ratio. Highest reflux ratio shows that it have the highest composition of acetone as the overhead product, and it also have the highest energy value in the condenser and reboiler. What that means? What that means by is the highest reflux ratio means there are more component or more amount that went back to the distillation column rather than we collected as distillate. So that means by we maintain the volume in the distillation column and then we collected the data longer and the time taken also will be longer. So we will obtain the highest composition or highest purity of acetone compared with other reflux ratio. Thank you.
For the feed stage, as you can see, feed stage is the stage where the feed is entering in the distillation column. For the energy in the condenser and the reboiler, the energy required is remain constant. However, the composition at the overhead and the bottom of acetone and acetic acid is decreasing. While this is so that as the feed is moved lower down the distillation column, the overhead composition and bottom composition become less rich. This shows that the lower of feed stage, the more gases feed passing through the trace of each stages. Therefore, the composition of acetone and acetic acid will become less and lesser. So from the conclusion, we can see from the result and discussion, the value of the composition of acetone and acetic acid changes as we change the variable which is feed stage, feed efficiency and the reflux ratio. And the stage of the distillation column. So this means that the Analysis is a good software to measure the composition of each of the product that we need for engineers to use.
Stated below here are the few sources that we use as our reference in our project.